Welcome to Math Challenge 520. In Math Challenge 520, we are going to find the ratio of the radii. You have got a circle inscribed in a right triangle. You have a circle circumscribing a right triangle and a semicircle inside a triangle, and the lengths of the triangles are all same 3, 4, 5. All the triangles are congruent, but in first case, circle inscribed means circle is inside. In second case, circle is circumscribed means circle is outside. And in the third case, it is a semicircle with the diameter along the hypotenuse. So over a cup of coffee, we can solve it in 2 seconds. It will not require more than 2 seconds to find the ratio of the radii of these circles or semicircles. Math Challenge 520. Let us solve it over a cup of coffee in 2 seconds. Now we take the first case where the circle is inscribed. Case 1 where circle is inscribed in a right angle triangle. The circle is inscribed means circle is inside. Hypotenuse 5, the legs are 4 and 3. The legs are 4 and 3, the hypotenuse is 5. So the radius is given by sum of legs minus hypotenuse whole divided by 2. Sum of legs 3 plus 4 minus hypotenuse 5 whole divided by 2. 3 plus 4 7 minus 5 2, 2 by 2 1. So the radius is 1 meter. When a circle is inscribed in a right angle triangle, the radius will be the sum of the legs minus the hypotenuse whole by 2. So here the radius is 1 meter. Sum of the legs 4 plus 3 minus hypotenuse 5, they giving you 2 whole divided by 2, 1 meter. Radius 1 meter. So remember the rule. Whenever a circle is inscribed in a right triangle, radius will be sum of legs minus hypotenuse whole by 2. Here we have got a circle which circumscribes, that means circle is outside. Circle circumscribes a right triangle, that means circle is outside. So when the circle circumscribes a right angle triangle, the hypotenuse will be the diameter. When a circle circumscribes a right triangle, the hypotenuse is the diameter, so the radius will be hypotenuse by 2. So for such a circle, a radius equal to hypotenuse by 2, because hypotenuse is the diameter. The hypotenuse is the diameter, so radius will be hypotenuse or diameter divided by 2, that is 5 by 2. So in this case, the radius is 5 by 2. So in case a circle circumscribes a right triangle, the hypotenuse is the diameter and radius will be half of the hypotenuse, here 5 by 2. Radius is 5 by 2. Now this is more interesting. We have a right triangle and a semicircle, the diameter along the hypotenuse. A right triangle, inside it a circle, the diameter is along the hypotenuse. Now the legs are 4 and 3. In such case, the radius is given by 1 by radius equal to 1 by first leg plus 1 by second leg. 1 by radius is equal to 1 by leg 1 plus 1 by leg 2. So in this case, 1 by 4 plus 1 by 3. So 1 by r will be equal to 1 by first leg plus 1 by second leg, 1 by 3 plus 1 by 4, giving you 7 by 12. 1 by 3 plus 1 by 4. 1 by 3 means 4 by 12 and 1 by 4 means 3 by 12. So 4 by 12 plus 3 by 12, 7 by 12. Now this is 1 by r. This is not r, 1 by r. So take the reciprocal, r is 12 by 7. So whenever you have a right triangle and inside it a semicircle in this position, the diameter coinciding with the hypotenuse. The relation is 1 by radius equal to 1 by leg 1 plus 1 by leg 2. So 1 by radius equal to 1 by 3 plus 1 by 4, that is 7 by 12, that is 1 by r. So r will be 12 by 7. So the required radius 12 by 7. So remember this formula. So once again we can recapitulate. Circumscribing circle, inscribing circle and inscribing semicircle. When a circle is inscribed, that means circle is inside. Circle is drawn inside. Inscribed in a right angle triangle, radius will be equal to sum of legs minus hypotenuse whole by 2. 4 plus 3 minus 5 whole by 2, that is 1. When a circle is circumscribing a right triangle, circumscribing, circle outside, circumscribing a right triangle, then radius will be equal to hypotenuse divided by 2. Half of hypotenuse, 5 by 2. And when you have a semicircle in a right triangle and the diameter is along the hypotenuse, 1 by radius equal to 1 by leg 1 plus 1 by leg 2. So 1 by r equal to 1 by 3 plus 1 by 4, that is 7 by 12, or r equal to 12 by 7. So the required radius, the required radii ratio, the ratio of radii 1 is to 5 by 2 is to 12 by 7. Multiply by 14. So 14 is to 35 is to 24. 14 is to 35 is to 24. This is the required ratio of the radii of these three circles. These three circles, the ratio of radii 14 is to 35 is to 24. First note that 3 square plus 4 square equal to 5 square. 3 square is 9, 4 square 16, 9 plus 16, 25, that is 5 square. So 3 square plus 4 square equal to 5 square, that is the triangles are right triangles. Each of the triangles is a right angle triangle. 3, 4, 5. 3 square plus 4 square equal to 5 square. So each of the triangles is a right angled triangle. That was our math challenge 520. Follow us for all school level math, junior and senior Olympiad math, and all competitive exam math. And remember that we have free online classes for all school students. All school students free online class both in English and Bengali once a week. So join our free online class, contact us now and follow us for school level math, Olympiad math and competitive exam math. So we shall meet again. Till then, thank you and goodbye.